Welcome to the last part. Now we are discussing about the electric switch. Switch is a device with the help of which an appliance can be connected or disconnected from the power source as per requirement in an electric circuit. In the figure shown here, you can see commonly lever type switches used in our houses. If the lever is in the up position, the switch is off, circuit is open. If the lever is pulled down, it makes the circuit, closes the circuit, and the circuit starts working. Important thing about the switch that it is always connected in the live wire. Here in the second figure, it is depicted how a switch is connected in the live wire. So neutral wire, which is at zero potential, it is directly connected with the appliance, for example bulb, while the live wire, which is present at high potential of 220 volt, is it connected with the bulb with the help of a switch. So when the switch is in the normally open position, circuit is open, both the terminals of the bulb are present at zero potential, no potential difference, so bulb is in the switched off state. But as soon as the switch is closed, by pulling the lever in the downward direction, the other terminal of the bulb is also at the 220 volt potential. So due to this potential difference of 220 volt between the live and the neutral wire, the bulb is now going to light up. So again, when we are going to switch off the connection by pulling the lever in the upward direction, the bulb will switch it off because its other terminal is also now present at 0 volt. Switches are always present in the live wire, not in the neutral wire, because if the switch is connected in the neutral wire, not in the live wire, what will happen? The live wire will always remain connected with the bulb. So if this is the bulb and this is the live wire which is directly connected with the bulb, one end of the filament, that means the whole filament of the bulb will now be present at a potential of 220 volt. Now if in this state, this is the neutral wire and the switch is now present over here, as soon as the circuit will be closed, potential difference will be created, circuit will work properly. When we break the circuit by switching off the switch from the neutral wire, circuit will again break, bulb will stop working, so function will be performed by the switch. But the problem here is that the now the filament of the bulb is now present at 220 volt potential. So if for some repair work or something else, a person now tries to remove the bulb, or it tries the touches this second wire which is also a 220 volt potential, this is going to provide a great electric shock to the person, because person's body will be at 0 volt because it is connected with the ground. So a state of electrical shock can be generated over here due to this faulty positioning of the switch in the neutral wire. So the function of the switch is not only to on or off the circuit, but it is also to keep the appliance always at 0 volt potential whenever the switch is in the off position. So in order to perform this function, the switches are always presented in the live wire, not in the neutral wire. Then there we have a socket. Socket is a fixture in a circuit which are normally connected on the walls, from which power can be delivered to a movable appliances like heater is there, TV is there, radio, oven, refrigerator. To these kinds of movable devices, appliances, power is delivered with the help of the fixture called socket. A 3-pin socket is shown in the figure, where pins can be labeled as pin number 1, 2 and the 3. Pin number 1 is the earth pin. Pin number 2 present on the right side, they are the live pins, and the other one on the left side, they are the neutral. So socket has 3 types of cylinders present inside it. Topmost cylinder longer and thicker in size is earth. Two lower cylinders of same length, same thickness, one present on the left side is for the live wire, one present on the left side it is for the neutral wire. These sockets deliver power to the movable appliances with the help of these 2-pin or 3-pin plugs. So plug is a device with which power is delivered to the movable appliances when these are connected or inserted inside the socket, and they deliver the power with the help of the cable or the wire. So in the figure you can see two types of the plugs, a 2-pin plug and a 3-pin plug. 2-pin plugs are normally used for those appliances which do not have the metal casing for their outer body. 3-pin plugs have a extra pin present at the top which is called as the earth pin. This is used for the appliances which are high power in nature or which have the metal body as the external casing. So for 2-pin appliances, one pin act as live pin, another act as a neutral pin. For the 3-pin appliances, the top pin is thicker and longer, which is used for the earth connection. One present over here is used for the live wire and another present over here is in the neutral wire. An important thing about the 3-pin plug is that earth pin is always thicker and longer because it has to serve two purposes. First purpose, that whenever we connect this plug, insert this plug into the socket, always a correct connection is provided so that by mistake earth pin doesn't get inserted into the live pin or into the neutral pin. So for this, a particular shape in a particular shape, the cylinders in the socket and the pins on the plug, they are arranged in a particular shape so that whenever plug is inserted into a socket, earth pin always goes into the earth cylinder, live and neutral pins always go into their respective cylinders in the socket. Second function is to provide the safety to the consumer. Earth pin is longer so that whenever plug is inserted into the socket, the metal body of the appliance with the help of this earth pin present on the plug is first one which comes in contact with the earth wire present connected to the earth cylinder onto the socket. Thereafter, when plug will be inserted properly in the socket, thereafter live and neutral wire, they will come into the connection with their respective neutral and live wire in the socket pin. This is for the safety of the appliance, so that due to any problem, if the current is leaking into the metal body of the appliance, so before the live and the neutral wire gets connected with the live and the neutral wire present in the socket, it should be the earth wire which must earth any kind of electric current running into the metal body of the appliance immediately into the earth. So this is done for the safety of the consumer. Then we use 3-core flexible wires, flexible cables, 3-core flexible cables or wire for delivering the current. A 3-core wire has 3 insulated wires present inside a common insulation. One wire is used for the neutral wire, other for the live, and one for the earth. Then there are high tension cables. High tension cables are actually the wires which actually transmit electrical energy, electric power from the generating station to the distribution stations. Here you can see in the second figure that long and wide poles are used for transmission of electricity from the generating station to the distribution plants. These high tension cables have electric potential of the order of 1,32,000 volt, or it may be 66,000 volt or 33,000 volt. These high voltage lines are always present at a huge height from the ground for the safety of the persons passing below it. Color coding of the wire. Whenever household wiring is done, in order to distinguish the wires, that which wire is acting as live, neutral and earth wire, all the three wires of different colors are used. So color code is used for identification. In the old convention, for a neutral wire, black was used for the neutral color, green color is used for the earth wire, and red was used for the live wire. But according to new accepted convention, neutral wire is having a color light blue, live wire is used for having a brown color, and earth wire that is used, it is having either green color or yellow color, or it is a mixture of both of them. So this is the color coding of the wires. At last, safety precautions. It is very essential to be very safe and cautious while using the electricity, because this can provide a great electric shock, and we are using alternating current at our homes for running various appliances. So alternating current is much more dangerous, because once somehow we get connected with a live wire, we will not be able to separate our body from the live wire. So that can be a dangerous situation. So that's why it is essential to be very cautious while using the electricity. So we can do certain things, that we do not touch the appliances or the switches with the wet hands. We do not insert socket into the plugs with barefoot or with the wet hands. We have to use always good quality cables and wires which have a good quality insulations. Each appliance must be provided with a sound fuse, so that due to overheating of an appliance, it is only the live wire which is connected to this particular appliance is getting switched off, not the other live wires connected with the other appliances. Each appliance which has a metal casing, it must be earthed properly for the safety of the consumer. So by following these kinds of safety precautions, we can be a good consumer while using the electricity. Thank you.